Okay, so we're going to graph quadratic inequalities. Last class we just did quadratic graphs. Your equations, not inequalities. The same steps are going to apply, okay? You're going to need to find the x value of the vertex using the formula x equals negative b over 2a. And then once you get that x value, you're going to plug it in to get the y value. And you're still going to make a table, just like we did last class, okay? Once you make that table, you plot your points. Now it's gonna, you're gonna have to determine if it's a dashed or solid boundary line. Okay, so if you remember when you do linear inequalities, if it's less than or greater than, what type of line is that? Dashed. And then if it was less than or equal to, greater than or equal to, then you would have a solid line. Okay, so the same rules are going to apply. You just now are graphing a parabola instead of a line. Okay, and then we're going to talk about shading. You're going to have to shade. So if you do all of 4.6 and you don't shade something, you missed half your problems. Okay, so if I'm looking at y is less than 2x squared, remember that standard form is ax squared plus bx plus c. Okay, well I don't have a b and I don't have a c. If you can look at that and recognize that the x value of your vertex would be 0, fantastic. But if not, you can go through the formula x equals negative. I don't have a b, so that's going to be 0. All over 2 times 2. Well, that's just going to give me 0. Okay? Now, when I take 0 for my x and plug it in, this is just going to be 0, so my y will be equal to 0 also. Okay, so my vertex is at 0, 0. So for my table, 0, 0 is going to be in the middle. And I'm going to do my two values less than 0 and my two values greater than 0. You could store these values for x and type your equation, but this is just a 2x squared. I think we can walk through that and just use our mental math. If you take negative 2 and square it, that gives you a positive 4. 4 times 2 is going to give me 8. If I take negative 1 and square it, that's a positive 1 times 2 is 2. 1 squared is 1 times 2 is 2 again. 2 squared is 4 times 2 is 8. Okay, so I'm going to plot those points on my graph. Once I plot the points, before I draw my parabola, I need to look back at my inequality symbol. It's less than. So is that going to be a dashed or solid line? It's going to be dashed. When you're doing your inequalities for quadratics, make sure that you extend your parabola all the way to the end of the grid, because you're separating that grid into two sections. You basically have inside the parabola and outside the parabola. Okay? So how are we going to know where to shade? Well, if you think about with your linear inequalities, we always said if it's greater than, you shade above the line. If it's less than, you shade below. Well, you've got a quadratic. Okay? If you think back to absolute value inequalities the first 6 weeks, then we did a test point. Okay, we don't have to do a test point. If you want to, you can. But we're going to look at starting at the vertex. Okay, if you start at the vertex, you can still consider going above versus below. Okay, so if I have my inequality is greater than or equal to, I would start at my vertex and I would go above my vertex, so I would go up. Okay, it doesn't matter what direction my parabola is opening, I would still start at the vertex and go up if it's greater than. Here, my inequality is less than. So I'm going to start at my vertex and I'm going to go down. That means this entire area outside of my parabola is my solution area. Okay, so when you're shading, the direction of opening for your parabola does not determine where you shade. It is starting at the vertex regardless of the direction of opening and going up or down. Okay? Alright. and then you're done. So if I were to choose any point in this area outside the parabola and plug it in, it would be true for this inequality. Okay? So my next example, I've got y is less than or equal to x squared minus 1. So I'm going to do x equals negative. I'm going to leave a spot for b over 2, leave a spot for a. Okay, if my standard form is ax squared plus bx plus c, I only have an a and a c, so my b is still 0 because I don't have an x term. And then my a is just 1. So my x value is going to be 0 for my vertex. So now if I plug in 0 for my x, 0 squared is 0, minus 1 is negative 1. So my vertex will be 0, negative 1. And then I still do my 2 points less than 0 and my 2 points greater than 0. And I think we can still do our mental math here. If you take negative 2, square it, that becomes a positive 4. Minus 1 is 3. Negative 1 squared is 1. Minus 1 is 0. 1 squared is 1. Minus 1 is 0. 2 squared is 4. Minus 1 is 3. Once you plot those points, you need to look at your inequality. It's less than or equal to. This time it's equal to, so that makes my parabola have a solid line. Okay, now it's less than, so I start at my vertex, and in what direction am I going to shade? Less than goes down, so I would go down, and all of this would be shaded. You're good with that? Okay, so now I've got y is less than negative x squared minus 2x minus 1. So for the x value of my vertex, I've got negative. What's going to be my b value? Negative 2. So ax squared plus bx plus c. So my sign goes with it. And then my a is negative 1. So my formula, x equals negative b over 2a, is where I'm getting this. Okay, ax squared, bx, and c. So my b is negative 2, my a is a negative 1, so negative negative 2 is a positive 2, divided by negative 2 would give me negative 1. Okay, now this has my full standard form, so we're going to take negative 1 and store it for x. And then we're going to type our equation, negative x squared minus 2x minus 1. That gives me 0. So y is equal to 0 when x is equal to negative 1. That's my vertex. So negative 1, 0 is going to go in the middle of my table. And I'm going to have negative 2, negative 3, 0, and positive 1. So you're going to still get those y values the same way we just did that. Store negative 3 for x. And you get negative 4 for y. Negative 2 store for x. You will get negative 1. When you plug in a 0, you get negative 1. And then when you plug in 1, you should get negative 4. Am I going to have a dashed or solid line? My inequality is less than, so it's going to be dashed. Okay? Less than, I start at my vertex and I go where? Down. When I go down, that falls inside my parabola this time. So I'm going to shade inside. So this is a reminder that no matter where your opening of your parabola is going towards, you're still just moving from the vertex. You understand that? Okay. So the next example, I've got y is greater than or equal to x squared plus 2x minus 8. I'm going to do the same steps for the x value of my vertex. I'm going to have a negative, and my b value is what? 2, all over 2 times my a value is 1. So negative 2 divided by 2 is negative 1. Take that negative 1, store it for your x. X squared plus 2x minus 8 should give you a negative 9. So my vertex is negative 1, negative 9. So when you store your negative 3 for x, you get negative 5. Negative 2 store for x, negative 8. 0 will give you negative 8. 1 store for x should give you negative 5. Okay, my inequality is greater than or equal to, so I'm going to have a solid line. I'm going to make that go all the way to the end of the grid. Then I go back to my vertex. If my inequality is greater than, where am I going to shade? Am I going to go up or down? Greater than goes up, so it falls inside my parabola. We good with this? Okay, we're going to skip the next example if y'all are good with that. We're going to move on to a system. Okay, so now you're going to do the same steps. You're just going to do it twice. Okay? And so your solution region is where the overlap shaded area falls. So we're going to shade our 2. This is where your 2 colors will come in hand if you use 2 colors. And then wherever those 2 overlap, that's your full solution area. Okay? So if I've got y is less than negative x squared plus 3, I'm going to find my vertex. Do I have a b? No, so it's 0 over 2 times negative 1. So my x will equal 0. Okay, so that will make my y equal what? Just 3. So my vertex is at 0, 3. So 0, 3 goes in the middle of my table. If I take negative 2 and plug it in for x squared, if you do the mental math, just make sure you understand that negative is after you square the negative 2. Okay, if you want to play it safe, you can always store the value and then type in your negative x squared plus 3. Gives me negative 1. Negative 1 store for x will give me 2. 1 store for x should hopefully give me 2. And 2 store for x should give me negative 1. I've just plotted the wrong point, so ignore mine right there. Now for this one, my inequality is just less than, so that's going to make it a dashed boundary line. It's less than, so I shade where? I go down, so it's inside my parabola. I'm going to lightly shade that. I'm not going to do it real heavy so that I can still see my second graph. So for my second graph, I do the same steps. I've got x equals negative. Now my b value is 2, all over 2 times 1. So negative 2 divided by 2 is going to be negative 1. So when I take negative 1 and store it for x and type in my x squared plus 2x minus 3, it gives me a negative 4. So my vertex is negative 1, negative 4. So take negative 3, store for x. That gives you 0. Negative 2, store for x. Gives you negative 3. 0 will give you negative 3. And 1 should hopefully give you 0. Now this time it's greater than or equal to. So I'm going to have a solid boundary. It's greater than, so from my vertex I'm going to shade up. So once you see that overlapped region, you can either highlight it, you can shade it darker, you can draw an arrow, whatever you need to do so that I can fully see that's my overlap shaded region. Y'all good with that? Okay. So now we've got y is less than 1/2 x squared minus 4x plus 5. When we do the x value of our vertex, we have x equals negative. Plug in a negative 4 for your b, all over 2 times 1/2. So that's going to be negative negative 4, which is positive 4. 2 and 1/2 is 1. So that's just going to leave me with 4. So I'm going to take 4 and store it for my x. And I'm going to have my 1/2 x squared minus 4x plus 5. And that gives me negative 3. So my vertex is 4, negative 3. Now, remember that when you have a fraction in front of your x squared, what do I have to do in my table? I'm going to skip some of those x values because I want only whole numbers in my table. So if I were to try to do a 3, I would end up getting a fraction. So I'm not going to do 3, I'm going to skip and go to 2. When x is equal to 2, I get my whole number of negative 1. If I were to try 1, I'm going to get a fraction again, so I'm going to skip till I get 0. When I plug in 0 to that equation, all of this would go away, so I have 5. So in the opposite direction, I'm going to skip my 5, and I'm going to go to 6, skip my 7, and I'm going to go to 8. So 6 stored for x gives me my negative 1. 8 stored for x will give me my 5. So remember that when you have a fraction for your a, you're going to have to skip count in your table. And then my inequality is less than, so I'm going to have a shaded, I'm going to have a dashed boundary. It's less than, so I'm going to shade downward, which falls on the outside. And then I'm going to repeat those same steps for the second inequality. X is equal to negative 2 all over 2 times negative 1. So negative 2 divided by negative 2 is going to give me 1. 1 stored for x, and I've got negative x squared plus 2x plus 6 gives me 7. So my vertex is 1, 7. This time I don't have to skip count because I don't have a fraction for my a value. So negative 1 stored for x gives me 3. If I plug in a 0, that leaves me with 6. I'm going to make sure 2 for x will give me 6, and 3 for x should give me 3. This time my inequality is less than or equal to, so I'm going to have a solid boundary. It's less than, so from my vertex I go down, and I'm shading inside that parabola. So my overlapped region is right here. You're good with that? Do we have any questions?